Hey guys, welcome to the channel. Today we're going to take a look at how to make your Python code run fast. Now I know that's vague, but in a nutshell what we're going to take a look at is we're going to take a look at asynchronous code execution. Don't change the channel. This is important. We're going to show you how to allow multiple tasks to run at the same time. Imagine you had 50 cards and you wanted to test, will my card render? And in order to do that, you have to hit an API for each card. Now, what if it took half a second to get a response back from the API? Will my card render? Now, if you had 50 cards, 50 times 0.5 is 25 seconds, right? But what if you had 5,000 cards or 500,000 cards? If you run your tasks sequentially, it will take linear growth for how long it takes the whole job to complete. But if I can run my code asynchronously, maybe I could say, hey, all 50,000 cards, do you render? If I could ask that question into the universe at the same time and then just kind of accumulate all of the responses when they come back, then the most time it will take is the API that took the longest to respond. So maybe it took 2 seconds, maybe it took 3 seconds, maybe it took 5 seconds. But the task would take 5 seconds if I can run my code asynchronously. If this sounds confusing to you, definitely stick around, because like I said, we're going to make your code run faster. No, really, what are we doing? We're going to take a page in Domo. We're going to get a list of all of the cards on that page. And then for each card in that list, we're going to ask whether or not it renders. Classic example. I've got here this beautiful dashboard. And most of the cards render except for the one. Maybe I updated the data flow. Maybe somebody changed it to beast mode someplace. But for whatever reason, this card doesn't work. Wouldn't it be great if I could just get a list of the broken cards? And you're like, Jay, visual inspection will take you a million miles, right? Yeah, for one dashboard. But what if I had 10? What if I had 50 dashboards? What if I had 50 dashboards spread across 20 or 30 instances of Domo that I had to manage, right? Visual inspection it's good, but automation is better. And that's what we do here at the channel. So not to talk about authentication. We've done a million videos about authentication. I'll leave some links in the description below. Um, but let's talk about the problem and how we're going to solve it. What I need to do is I need an API that will give me a list of all of the cards on a page. Then, once I get a list of all of those card IDs, I need to loop over each of those card IDs and ask, does the card render? So that's the mission. My first function here says get cards on a page. We're going to hit the stacks/cards API. We're going to use our good old-fashioned XDomo authentication with a session token. Guys, this is the important part here. We're going to use a request library to send a get request. Now I'm focusing on the request library because the requests library runs code synchronously. It runs code one at a time. And we're going to see that in just a second, how painful that can be. So to retrieve my data, I'm going to run my get cards on page function. I'll pass in my authentication. I'll pass in my Domo instance, and I want to get data for this page. Cool. I get my results. Oh, guys, I don't want to spoil it. Let me reset my kernel so you can just we can all see it happen in real time. All right, let me get my session token again. All right, so I get my result. Now, of all of this stuff that I care about, I really only care about my list of cards. And within my list of cards, I really just care about the card ID. All the rest of this, I really just don't need. So I'm going to use a technique called list comprehension. So get cards from the data that was returned, store it in cards list. And then for each card in my card list, for now, we're just going to print the ID. This is what's called a list comprehension. In JavaScript, we would have done like a for each or a map, right? We would have used a different function to get this done, but in Python, we love our list comprehensions. This is a Googleable term. I didn't make it up, so you can go do that. Now we're going to see two different variants of list comprehension. One, I can write for card and card list, colon, and then indented do stuff. Alternatively, I can write for card and card list, do stuff, but only if it's one command. So in this case, I'm saying for each card in the card list, get the ID and store it in a list that we're going to call card list. And that's what that looks like. I now have my list of cards. Now I need to I need to loop over this list of cards and ask, is my card broken? And this is the real meat and potatoes of the synchronous, asynchronous stuff. So it's not, the most exciting thing in the world, but it's going to make your code faster if you can understand this. So to help illustrate all of this, I'm going to start by asking what time is it? And I'm just going to capture the time right now. The time when I started asking, is this card ID broken? Because I'm going to run this same function 5 or 6 times, right? We're going to hit our render API. And if my card renders, it's going to give me a 200 response and tell me about the render. And if it doesn't render, it's going to give me a 400 response and tell me why it can't render. Again, we're still using our request library. But something interesting that I've thrown in here is I've said, put my code to sleep for 2 seconds. Just stop for 2 seconds. And then capture what time it is. And I'm choosing 2 seconds to just illustrate the point, because when I'm hitting APIs can take half a second to respond. They can take what feels like no time to respond. They can take 2 minutes. So I'm putting my code to sleep so we can just feel it and see it as the code executes. Now my response is going to be the same for true or false. I'm going to return my start time, my end time, and the card ID. And if I got a 400 error, it means my card doesn't render. So renders is false and give me an error message. If it's not a 400 error, then I assume my card does render. So return true as well as the message. All right, so that's my code. Just to see this in action, we're going to run 2 iterations of is card broken in sequence. We're first going to run it for this card, then we're going to run it for that card. One card works, the other one's broken. In that moment that felt like an eternity, right? It took 2 seconds for my first response. And then after that 2 seconds, it could start the next job, which took another 2 seconds. For a total of 4 seconds, right? But what if I had to run it across every card in my card list? Again, we have our list comprehension here. I'm just talking to fill in the time because this is painful. Waiting 2 seconds for each to execute. Now that's just 20 cards. What if I had 200 or 2,000, right? This would feel really slow. And you're like, Jay, but all you have to do is take out this sleep. But I'm just doing this to prove the point. If I wait and do this in a sequence, it takes longer. Doesn't matter if it takes half a second, right? At 25 cards or 250 cards, that's still a lot of half seconds. Okay, so what's the dream? Our dream state is asynchronous code execution. Our dream state is to say, hey, what if I kicked off all of these at the same time? And then it doesn't matter if it took 2 seconds or 3 seconds or 5 seconds. If I could start all of these at the same time, the longest it would take to run the job is the time it took the slowest API to come back. So maybe it takes 5 seconds, but still, 2,000 cards in 5 seconds. It's not bad. And that's what we're looking for with asynchronous code execution. Now async, you're going to see async in front of the function declaration. So I'm saying, hey, is card broken? That's a function that is allowed or is able to run asynchronously. What does asynchronous mean? It means in real terms, hey, Python, do something else while we wait for this function for that card to run. Like, I don't know, start the next card. So I don't have to wait. I don't have to wait in between to start the next task. I can do something else with my free time. Okay. So we have a lot of similar stuff going on in here, but this time, instead of using the request library, I'm using AIO-HTTP's session to send my put request. Everything else about this is the same, except for I have the keyword await within the function definition. And you're like, Jay, we're all about running code asynchronously. You're right, we are. We want our code to run asynchronously, but for this card, before I can turn my response into JSON, I have to wait for a response from the API. I can't go on to the next step until I have a response from the API. And you're like, well, how long could that take? Well, here I am in LA, right? My request has to get from my computer in LA through the Wi-Fi, which is dodgy and slow, over to Utah, from Utah to the server, and then it's got to hit the server and say, hey, server, do you have this API? And then, the server authenticates, it gives me data back, and then I have to route back from Utah back to my desk. So how long does it take for an API response to come in? It could take half a second. It could take 5 seconds. We don't know. All I know is that before I can convert the response into JSON, I have to wait for a response. If I don't wait for the response, in JavaScript, we call this a promise. A promise says, I promise you I'll get you an answer. I promise you there's going to be something. I just don't have it yet. And with await, I'm saying, well, I'm going to wait until you resolve the promise. That's JavaScript. In Python, we call it a coroutine. More on that in a moment. Okay, anyway, so again, all we did is we used the session library from AIO-HTTP instead of using a request. And we added the keyword await in front of anything that could take an indeterminate amount of time. Cool. So this is the part you guys all care about. You're like, I just want to see the code work. So let's see the code work. You'll notice all of the code came back in 2 seconds. All of it. Every request. And it could have been 20 cards. It could have been 2,000 cards. It would still take 2 seconds. Why? Because with asynchronous code, what I'm saying is, hey, for each card in my card list, start is card broken. And it's asynchronous, right? So it says, oh, well, I don't have an answer yet, so why don't you do something else with your free time? I can say, oh, let me start the next card. 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 So I can start all 2,000 cards pretty much at the exact same time. And all I have to do is wait the 2 seconds to get a response from the first card. And when it gives me that response, I do something. I append the response someplace. And then whenever the next one's in, the next one, whenever they come in, I just do the next processing step with that card. Now, it could be that this card comes in later than that card. We don't know, we don't care. All we know is we're going to wait until all of them are done before I go on and process the print command, which is why we saw all of the code print at the same time. We're going to dig into this and kind of the nuances in just a second here, but let's kind of walk through this. So what do? We declare an empty array called tasks. Sorry, an empty list called tasks. And for each card in the card list, I'm going to send the isCardBroken function. I'm going to append it to tasks. Oh, wait. I'm not waiting for the response. I'm just saying, hey, start it. And then take whatever this is and put it into tasks. Now here, In asyncio.gather, I'm saying gather all of the tasks, wait till the tasks have resolved, and put that result in a variable called tested cards. So here, what's happening is we're saying, hey, I've got 20, 30, 50, 100 asynchronous tasks. I don't know when they're done, but whenever the last one's done, move on to the next step. And again, maybe it took 2 seconds, maybe it took 2.5 seconds, maybe it took one task 4 seconds. They all started pretty much at the same time. So the slowest processing all of these will take is however long it takes the slowest API to return a result. As opposed to this model here, where it said, hey, I can't start the next card until the previous one finishes. Synchronous, asynchronous. That's it in a nutshell. If you can figure out how to run your code asynchronously, everything will be faster. But let's dig in a little closer to what's happening here. So I'm going to store this as a result, and then I'm going to print the result. So remember, is card broken was declared as an asynchronous function. It says, hey, you can do other stuff before you go on. You can do other stuff with your time while we're waiting for a response. But what happens if I don't await? What happened is card broken is a coroutine. In JavaScript language, it's a promise. I promise you there's going to be some data. But at the time that I printed the response, my promise was still a promise. It wasn't data. It was a promise. And so I see this coroutine object thing. It doesn't mean anything. It's just a promise that eventually there's going to be stuff. Now, if I await, now I'm saying, hey, I don't want your promises. I want data. So I'm going to wait until I get data back. And now we're back to each code block taking 2 seconds to run. And you're thinking, but Jay, you said this is an asynchronous function. Yeah. It is an asynchronous function, but you said wait. You said wait until there's a response before you do something. And this is kind of back to what we originally had, so this isn't helping us. So what do we do instead? What we did instead was we said, I don't know why my headphone keeps turning off, but it just did there for a second. Anyway, so what we did in the right way of handling things is we said, hey, create an array called tasks. And instead of awaiting execution and then taking the results, instead of doing this, because this would still take 2 seconds at a time, instead of doing that, don't wait for a result. Just take this and append it to tasks. So what is tasks? Tasks is now a list of coroutines. Tasks is a list of promises. I promise you I'm going to get data. I don't know when, but I promise you eventually there will be data here. To prove that, if I print tasks, I just get a list of coroutines. I have a list of promises. Eventually there's going to be stuff there. Well, how do I get stuff there? Remember, we used asyncio.gather. That said, and this says, if I await it, this says, hey, wait until all of these promises have been resolved. Wait till I have data from each of these functions and then do something. So I can take the result of asyncio.gather and store it in real data, and I'll print real data as well as tasks. tasks is at the time of code execution, tasks just contains promises that eventually I'm going to get data. We don't care about your promises. What I care about is the data. So I have to do asyncio.gather, wait for all my tasks to execute, store them in real data, and then print real data. Okay, so again, just so we can see it run instantaneously, run my code, 1, 2, and then I get my result. You're probably wondering about this unclosed client session error. Remember, the session is how we navigate. It's how we navigate to our server. And the performance gain of using a session that persists is because once I know how to navigate from LA to Utah, I don't need to pull out Google Maps again. I just know how to get there. So I can recycle my session to get to the server quickly. But at the end of code execution, when I've finished resolving is card broken, I should await session.close. I should close the session, and that will make my error go away. Cool. That's a tutorial, guys. Again, I know it seems super technical and it seems like a lot, but our whole goal in this is to make our code run faster. Very real use case. I was working on a challenge where we had hundreds of instances of Domo, and I wanted to capture the activity log from hundreds of instances of Domo. And I could wait, hey, instance 1, give me your activity log, wait 5 seconds, upload it to Domo, wait 5 more seconds. Hey, instance 2, wait 5 seconds, upload to Domo, wait 5 more seconds. I could do that, and it would take half a day to process all of those instances. Or I could say, hey, you know what? All 500 instances, give me all of your data all at once. Upload all of my data all at once. And then whenever you're done, I can move on to the next step. And that's the real power of this asynchronous code execution. I hope you guys found this useful. You guys know where to find me in the Domo Dojo or join the Slack user group. I'll leave a description I'll leave links in the description. I'll catch you guys later.